Okay, in this video, we are going to look at a couple examples of limiting reactant problems. This is a special type of stoichiometry problem that you are going to recognize because it has not just one given amount that you're going to start the problem with, but it actually will give you two starting amounts. They're solved just like the stoichiometry problems, but again, you're just going to notice them right away because you will be given an amount of each reactant that is present. So you're kind of needing to solve two problems at once. So for this limiting reactant, you want to read conceptually behind like what a limiting reactant is, why it's important. All of that should be in your textbook under this section. I'm just picking up with like the math portion of it just to provide a couple extra examples to hopefully clarify how the problems are worked through. So limiting reactant problems look just like our stoichiometry ones. You're going to be given an equation and then you are going to be given an amount of each reactant that's present. So in this one, I'm told that I'm starting with 10.27 grams of each reactant. So that means 10.27 grams of the sodium, 10.27 grams of the HCl. So I'll just put a little note here. That's how much we're starting with each of them. And my question asks, how many moles of hydrogen can be produced if I start with that many grams of each reactant? Okay, so the way that we approach these is just like hopefully how it would seem, is that since you have two starting amounts as opposed to just one like we've looked at previously, you're going to do this problem twice. With each of the amounts that's given. So the first one we'll look at is the sodium. So we'll go ahead and start our problem with a 10.27 grams of sodium. And we are going to do these separately. I'm going to convert sodium over to the hydrogen, and then my second problem will be converting the HCl over to the hydrogen. So since I want to convert sodium to hydrogen, like we talked about, the only step that's going to allow me to change from sodium to hydrogen is the mole ratio step. So in order to use that mole ratio step to change my units of sodium over to hydrogen, I have to put it into moles. So that first step, grams of sodium is on top, so I'm going to put that on the bottom. And my first step is to take those grams of sodium and put it into moles of sodium. And we've talked a lot about now how you do that is by taking the molar mass of sodium on the periodic table, and that'll put us into moles. So the next thing that I want to do, now that I'm in moles, now I can use the mole ratio to actually change from talking about sodium over to hydrogen. So since moles of sodium is on the top, I'm going to put moles of sodium on the bottom, and then moles of the substance that the problem's asking about, which is hydrogen. And outside of our like basic conversions, when we're in the mole ratio step, this is the only place that our number of moles can be something other than 1. So the way we get these numbers is by looking at the balanced chemical equation. If I look up sodium first, sodium has a coefficient of 2, so that 2 will go here. Hydrogen has no coefficient in front of it, so I know that means it's 1. So this tells me now that I have converted over to moles of hydrogen, that's what it asks for, that if I started with 10.27 grams of sodium and I had enough of the other reactant, that I could potentially produce 0.2234 moles of hydrogen. Okay, so that's my first possibility. I then have to do this problem again with the amount that I'm given of the second reactant, which I'm told it's going to be the same mass. So 10.27 grams of HCl. And I want to do a prediction of how much hydrogen, moles of hydrogen that I could produce if I had just this amount of grams of HCl and assumed to have enough of the other reactant. So if I go ahead again, same thing, since I want to change from HCl to just hydrogen, I have to be in moles so I can use the mole ratio step. So my first step is going to be a conversion from grams of HCl to moles of HCl. Outside of the mole ratio, the number of moles is always 1, and if I'm asked about grams, I have to add up all of my masses in that compound, and if I do that, I should get 36.458. Now that I'm into moles, my next step is going to be using the mole ratio to change from HCl over to the substance that the question asks about, which is hydrogen. So when I'm in the mole ratio, that's where I have to use the coefficients from the balanced equation. HCl, if I find it, it has a coefficient of 2, and hydrogen, that has a coefficient of 1. And the problem just wants me to end in moles of H2. So if I go ahead and do that, I should get 0.2817 moles of H2. Now, only one of these can be the theoretical yield, which is what we define as, if you were to do this experiment perfectly, how much of this product would you be able to make? And if I look at the two numbers, your answer of which is your theoretical yield, or which one is the correct amount, is always going to be the smaller of the two numbers. So in this case, if I compare the two of them, this here is going to be my answer that I would actually give if this was a test. This is called my theoretical yield, and that is the amount that can theoretically be produced. This larger amount will not happen because there's not enough of the other one. Okay, so that would be your answer. And then usually the last part of the question, typically there's two pieces of the question. One, it will ask like, what is your theoretical yield? And it's always going to be the smaller of the two numbers that you end up with. And then the second part of the question is usually, what is your limiting reactant? And very simply, when you find which of these two numbers is the smaller one, and therefore your theoretical yield, you go back to the beginning, and the reactant that gave you that smaller amount is your limiting reactant. So I would write Na is my limiting reactant. Okay, let's try one more of those just so you could see. So in this case, I have N2 plus H2, and I'm producing NH3. I'm told that I have starting with 38 grams of nitrogen, and I'm starting with 5.3 grams of hydrogen, and I want to know how much of the NH3 is going to be produced. So I know this again is going to be a stoichiometry, a mole ratio step, because I'm given information about one substance but asked to find out the amount of a different substance in the problem, or in the equation. So again, I'm just going to work these out, two separate problems. I'm going to start with my 38 grams of nitrogen. And I'm first going to take the nitrogen amount and convert it over to the amount of NH3, and the problem is specifically asking me to go to grams. So I'm going to go ahead starting this. I know that my first step has to be to moles. That's the only way I'm going to be able to use the mole ratio step, which is going to take me from one substance to a different substance. So grams of N2 to moles of N2. Outside of the mole ratio, the number of moles is always 1. Whenever I'm asked for grams, that's adding up the molar masses of those elements. Again, that was back in Unit 2. Now that I know moles of nitrogen, I can go ahead and do that mole ratio step to take me out of nitrogen and into the substance that the problem asks about, which is NH3. The numbers for mole ratio come from the balanced chemical equation. So if I find nitrogen, there's no number in front of it, so that's going to be a 1. If I find NH3, that has a coefficient of 2, so the 2 goes there. Now this problem wants me to go all the way to grams of NH3. Right now I'm in moles of NH3, so I'm going to have one last step, taking me out of moles and into grams of NH3. So outside of the mole ratio, the number of moles always gets 1. Grams is going to be the mass of, now I'm transferred into NH3. So if I add up NH3, you should get 17.034 grams. And then if I find that calculation, you should get about 46 grams of NH3. Right, now we're going to go ahead and take a look at the next one, which is hydrogen. So I have 5.3 grams of hydrogen. And same thing, I want to know if I have that much hydrogen, what is the predicted amount of NH3 that I could produce? So in order to change from hydrogen to NH3, I need to do the mole ratio step. In order to do the mole ratio step, I have to make sure that I'm in moles. So I know outside of the mole ratio, the number of moles is always 1. My grams is my total mass of 2 hydrogens, which is 2.016. Moles of hydrogen is on top, moles of hydrogen goes on the bottom, and this is where I'm going to go ahead and use my mole ratio to convert over to that NH3. When you're in the mole ratio, you have to use the balanced chemical equation for your numbers. So hydrogen, if you look it up, is a 3, NH3 is a 2. The last part of this is taking me out of moles of NH3 into grams of NH3. So from moles to grams, this is just my basic conversion. Outside of the mole ratio, the number of moles is always 1. And my grams, we already added it up here, 17.034. And if you multiply across the top, divide by the bottom, you should get about 33 grams. So this is the part where I have to pause. I have to compare my two answers. You always go with the smaller number. That is going to be our theoretical yield. This will not happen. Don't use it for anything. It's not possible because you will run out of this before you would ever get to that amount. So you always go with the lesser amount whenever you are calculating your theoretical yield for a problem. And like I said, typically the question for limiting reactants comes in 2 parts. The first part is, what is your theoretical yield? And that's what we've been working through. And the second part is, which is your limiting reactant? Meaning, in this reaction, which one of your reactants is going to run out first? And the way that you know that is you go to that lesser amount, that theoretical yield, follow it back to the beginning. The reactant that gave you that smaller amount is going to be your limiting reactant. So LR, limiting reactant, is hydrogen. That's it.